In example 1, we need to solve and also justify the equation. When we solve it, our steps are going to go here on the left, and then our justification is going to go here on the right. So if we look at x minus 10 is equal to 2, right now I'm seeing that there's two terms on the left of the equal sign. There's an x and there's a negative 10. If we want the x to be by itself on the left side of the equal sign, we'll need to add 10 or do the inverse of subtraction here. So we'll add 10 to each side of the equal sign. Another very important thing when you're solving. Do the same thing to each side of the equal sign. You'll maintain the balance of the equation then. So negative 10 plus 10 is 0, and we'll just have x. 2 plus 10 is 12. Our justification could be a couple things. One, we could write down what we did. So we could put add 10 to both sides. Or, if you're looking for a property, this is the additive property of equality. The additive property of equality simply states if you add the same thing to each side of an equal sign in an equation, then the result will be an equivalent equation. What I mean to say is that if you add the same thing, you'll maintain the balance as long as you add it to the left and the right side. So add 10 to both sides, or the addition property of equality. The next example, we have 5a is equal to 150. So we only have one term here. We're going to try to get rid of this coefficient. This coefficient 5 is being multiplied by the a, so we're going to divide by 5 on each side. A will be equal to 150 divided by 5, which is 30. Keep in mind that you can substitute these values back in the original equation. All you're doing here is looking for the value that makes the equation true. For these problems, there's only going to be one value. There could be no values, an infinite number of them, or several of them, depending on what type of equation you have. But for this, 30 is the only one. 5 times 30 is 150. You might have been able to figure that out in your head. You know, like 5 times a number is 150. It's got to be 30. And that's fine for these simple ones, but as we move on with some more complicated examples, then what you're going to need to do is you're going to need to learn those algebra skills, which is what we're teaching you here. So anyways, we've got a is equal to 30. What did we do to each side? We divided by 5. This is the division property of equality, which states that if you divide the left and the right side of an equation by the same thing, you'll wind up with an equivalent equation. The one below here on the lower left-hand side, we've got the p, or the variable, on the right side. That's fine. So we can separate the terms. We've got p and then a positive 11. Whenever we move terms or get rid of a term, we need to add or subtract it. We never multiply or divide a term. We'll subtract by 11 because we're adding 11 here. We want to do the inverse. I'm going to switch sides. I'm going to put the p over here on the left-hand side. That's normal to write the variable on the left-hand side. And then we'll write negative 16 minus 11 on the right-hand side. These are two negative values, so we're going to see a larger negative value. Don't like saying larger negative value, I guess, but just a lot of negatives together. So negative 16 minus 11, that's going to be negative 27. Our justification, we subtracted 11 from each side, or from both sides. If you want to write from each side, that's fine. This is the subtraction property of equality, which states that if you subtract the same thing from the left and the right side of an equation, you'll wind up with an equivalent equation, so you won't change this balance. If you only subtracted 11 from one side but not the other, this side would then be heavier than the other side. You'd be taking away some weight, or this side would be heavier than the other. With x minus 2 is equal to negative 7, we again have two terms, this time on the left-hand side, so we'll add the 2. X is equal to negative 2 plus 7, which is negative 5. In this case, we're going to be adding, or add 2 to both sides. And this again is the additive property, or the addition property of equality. I should have put divided by 5 to both sides up here, so please make a note of that. You've got to do your division or your addition or subtraction or multiplication to each side of the equal sign. We've got a few left to do here for example 1. These work in much the same way. We're going to look and see if we can identify the operation between the variable here and the coefficient, and its multiplication. So we'll do the inverse of that. We'll divide by -3. We need to divide on each side by -3. Matter of fact, if you want, you could put that down right away. Divide by -3 on both sides, or on each side. So we'll have x here. -3 divided by -3 is 1. We're left with x. We have a negative divided by a negative, which is a positive. I like to do my signs first when I do multiplication or division. You could even do that with addition or subtraction if you wanted to. And then we just have to worry about the 27 divided by 3, which should be 9. If you plug this value back in, or substitute this value back in, -3 times 9 is -27. So 9 is the value that makes the equation true. Sometimes there's more than one, but for this one, it's just going to be the 9. This next example, we have a number x divided by -3 is equal to -5. We're dividing here, so we want to multiply each side by -3. If you prefer to put -3 over 1, you can do that, no worries. And this side I got to do the -3 as well, almost forgot my negative sign. That'll help you keep track of where the -3 belongs if you were to write it as a fraction. Totally belongs in the top. So these guys will cancel. We'll be left with x on the left-hand side, and then negative times a negative is a positive. 5 times 3 is 15. We could also reason through this and say that if x is 15, 15 divided by -3 would be -5. So this does work. What we did to each side will go here, and so we multiplied by -3. This is the multiplicative property of equality, which states that if you multiply the left and the right side by the same value, then you'll produce an equivalent equation. You won't unbalance it, in other words. X plus 10 is equal to -25. This one, I'm seeing two terms on the left. We're going to subtract 10 from each side. X will be -35. Here we have 25 negative things. We're combining that with 10 negative things. So we'll wind up with a bigger negative number, -35. -35 plus 10 is indeed -25. What we did is we subtracted 10 from each side. And this is just the subtraction property of equality. Here we're dividing x by 2, so we'll multiply by 2. 2 over 2 is 1. If you prefer to write it as over 1, you can. X then will be -6 times 2, which is -12. Remember, a negative times a positive is a negative, and then you can focus on the 6 times 2. -12 divided by 2 is -6. So -12 is the value that makes the equation true, or balances it out. Over here on the justification side, what we did to each side is we multiplied each side by 2.